What if I told you that every single thing you believe about time is wrong? What if the past isn't behind you and the future isn't ahead of you? What if this moment, right now, isn't disappearing into nothingness as you experience it? And what if I could prove to you, using nothing but logic and simple thought experiments, that time is completely different from what your intuition tells you? Stay with me, because I'm about to dismantle everything you think you know about time. And I promise you, by the end of this, you'll never look at a clock the same way again. My name is Albert Einstein, and I destroyed time. Not literally, of course, but I destroyed the concept of time as humanity had understood it for thousands of years. I showed that time is not absolute, that it doesn't tick away uniformly for everyone everywhere, that it bends and stretches and slows down and speeds up, that it's woven together with space into a single fabric, that it's relative, fundamentally, profoundly relative. And today, I'm going to explain exactly what that means. Not with complex mathematics, not with equations that only physicists understand, but with simple ideas, clear explanations, thought experiments that anyone can follow. Because this isn't just abstract theory, this is about the nature of reality itself, about what it means to exist, about what now actually is. And I guarantee you, once you understand what I'm about to share, your entire worldview will shift. Let me start with what you think you know about time. You experience time as flowing, like a river, carrying you from past to future. You remember yesterday, you experience today, you anticipate tomorrow. This feels obvious, universal, like the most basic fact of existence. Time moves forward, always, constantly, 1 second per second, the same for everyone, everywhere. This is what philosophers call the common sense view of time, and it's completely wrong. How do I know? Because I proved it. With thought experiments, with mathematics, and then, crucially, with experiments that confirmed my predictions. Time is not what you think it is, and I'm going to show you exactly why. Let me tell you about the moment I first glimpsed this truth. I was 16 years old, still in school, and I had a question that wouldn't leave me alone. What would happen if you could ride alongside a beam of light? If you could travel at the speed of light, moving right next to a light wave, what would you see? Would the light wave appear stationary to you, like a frozen wave in the ocean? This question haunted me, because according to the physics of the time, according to what we understood about light and motion, if you moved at the speed of light, you should see the light waves standing still. But that created a problem, because the equations that describe light, Maxwell's equations, don't allow for stationary light waves. Light has to move, has to oscillate. Standing still isn't an option according to the mathematics. So there was a contradiction. Either the equations were wrong, or our understanding of motion was wrong. And I spent years thinking about this, turning it over in my mind, trying to resolve the contradiction. And eventually I realized something shocking. The problem wasn't with the equations. The problem was with our assumptions about time. We assume that time is the same for everyone, that if I measure 1 second and you measure 1 second, we're measuring the same thing, the same duration, the same interval. But what if that's not true? What if time itself depends on how you're moving? What if your speed affects how fast your clock ticks? This seemed absurd, ridiculous, obviously wrong. But the more I thought about it, the more I realized it had to be true. It was the only way to resolve the contradiction, the only way to make the physics work.
And in 1905, I published a paper that changed everything on the electrodynamics of moving bodies. This was special relativity, and it destroyed the absolute nature of time. Let me explain how. Imagine you're standing on a train platform, and a train rushes past you with incredible speed. Inside the train, someone is holding a flashlight. They turn it on, pointing straight up, and they watch as the light travels up to the ceiling of the train. From their perspective, inside the train, the light travels straight up, straight path, simple. Now here's where it gets interesting. Light always travels at the same speed. This is a fundamental law of physics. The speed of light is constant, always, for everyone, no matter how you're moving. This has been confirmed by countless experiments. It's one of the most solid facts in all of physics. So if light travels at the same speed for both observers, but it travels a longer path from your perspective on the platform than from the perspective of the person on the train, then something has to give, because speed equals distance divided by time. If the distance is different, but the speed is the same, then the time must be different. The light takes longer from your perspective on the platform to reach the ceiling of the train than it does from the perspective of the person on the train. Time itself is passing more slowly for the two of you, not because of some illusion, not because of a measurement error, but fundamentally, really, time is actually passing more slowly for the person on the train relative to you. Your clock ticks at a different rate than mine, and this isn't philosophy, this isn't speculation, this is experimentally verified fact.
We've measured it with atomic clocks on airplanes, with particles in accelerators, with GPS satellites orbiting the Earth. In every case, moving clocks run slow, exactly as relativity predicts. So, when I say time isn't what you think, I mean it literally. Time is not a universal river flowing at the same rate everywhere. Time is personal, local, dependent on how you're moving through space. This is the first shock, but it's just the beginning, because there's something even stranger, even more profound. Let me tell you about simultaneity, about what it means for two events to happen at the same time. You think this is obvious. If two things happen at the same moment, they're simultaneous, simple. But here's the problem. What does the same moment mean? The same moment for whom? Let me give you an example. Imagine you're standing exactly in the middle of a train car, and at the exact same instant, from your perspective, lightning strikes both ends of the train, front and back, simultaneously. You see both flashes at the same time, because you're equidistant from both ends, and light travels at a finite speed. So you conclude that the lightning strikes happened at the same time. Makes sense, right? Now imagine someone standing on the platform as the train rushes past. They also see both lightning strikes. But here's the thing. From their perspective, the train is moving. So when the light from the lightning strikes reaches them, the train has moved. The back of the train has moved toward where the lightning struck. The front of the train has moved away from where the lightning struck. This means, from their perspective, the light from the back lightning strike reaches them before the light from the front lightning strike. Not because light is traveling at different speeds, but because the distances are different due to the train's motion. And when they account for the travel time of light, when they calculate when the strikes actually happened, they conclude that the lightning struck the back of the train first, then the front, not simultaneously. So you, on the train, say the strikes were simultaneous. They, on the platform, say the back strike happened first. Who's right? The shocking answer is both of you. There is no absolute simultaneity. Events that are simultaneous in one reference frame are not simultaneous in another reference frame.
At the same time is not an absolute concept. It depends on your motion, your frame of reference. This is staggering. It means there is no universal now, no present moment that everyone shares. My now is different from your now if we're in relative motion. And this has profound implications. It means the past and future are not absolute either. Events that are in my past might be in your future, or vice versa, depending on how we're moving. The universe doesn't have a single timeline. It has countless timelines, one for each possible state of motion, and they're all equally real, all equally valid. None is more correct than any other. This is what I mean when I say time isn't what you think. It's not a single universal flow. It's a web of different perspectives, different reference frames, different experiences. All valid, all real, but all different. Now, let me tell you about something even stranger, the relationship between time and space, because they're not separate, they're not independent, they're woven together into a single entity, space-time. Here's how I realized this. If time dilation is real, if moving clocks run slow, then something else has to happen, length contraction. Objects in motion shrink, not because of some physical force compressing them, but because space itself is affected by motion in the same way time is. Let me explain. Imagine you're measuring the length of that train. If you're standing on the platform and the train rushes past, you measure its length by noting where the front and back are at the same time, simultaneously. But we just established that simultaneity is relative. What's simultaneous for you on the platform is not simultaneous for someone on the train. So the length you measure, which depends on identifying the front and back at the same time, that length depends on your reference frame. And it turns out, from your perspective on the platform, the moving train is shorter than it is from the perspective of someone on the train. Space contracts in the direction of motion, just as time dilates.
This symmetry, this connection between time and space, it suggests something profound. That they're not really separate entities, that they're two aspects of the same thing, space-time. A four-dimensional fabric where 3 dimensions are space and 1 dimension is time. And motion through space-time, what we call velocity, is really just rotation in this 4-dimensional space. When you move through space, you're rotating in space-time, and this rotation changes how you experience the separation between events. How much of that separation appears as spatial distance and how much appears as temporal duration. This is why time and space get mixed up when you're in motion, why moving clocks run slow and moving objects contract. You're literally viewing space-time from a different angle, a rotated perspective. And from that perspective, the balance between space and time is different. This is general relativity's foundation. But even in special relativity, we see this unity. Space and time are not separate, they are space-time. And understanding this, really grasping it, changes everything. Because it means time is not some separate thing flowing independently. It's part of the structure of reality itself, part of the fabric of the universe. And that fabric can be bent, stretched, warped. Which brings me to the next shock, gravity. You think gravity is a force, something that pulls objects together, but I showed that's not what gravity is. Gravity is the curvature of space-time. Let me explain. In special relativity, we deal with flat space-time, no gravity, no acceleration, just uniform motion. But the universe isn't flat, it has mass, energy. And mass and energy curve space-time, they warp the fabric. And objects moving through this curved space-time follow curved paths. That's what we call gravity, not a force, but geometry. Here's a thought experiment.
Imagine you're floating in space, no gravity, no forces, just you stationary or moving at constant velocity. Now imagine a massive object like the Earth appears nearby. What happens? In the old view, Newtonian gravity, the Earth exerts a force on you, pulls you toward it. But in my view, the Earth curves space-time around it, creates a depression, a warping, and you, following the straightest possible path through this curved space-time, that path appears curved to an outside observer. You fall towards the Earth, not because of a force, but because you're following the geometry, like a ball rolling down a slope, except the slope is in space-time itself. Now here's where time comes in. The curvature of space-time isn't just spatial, it's temporal too. Time itself curves near massive objects, runs slower. If you're standing on the surface of the Earth, your clock ticks slower than a clock high above you. Not by much. The Earth isn't massive enough to create a huge effect, but it's measurable, and it's been measured. Clocks at different altitudes tick at different rates. Time runs slower in stronger gravitational fields. This is gravitational time dilation, and it has practical consequences. GPS satellites orbiting high above the Earth experience weaker gravity than receivers on the surface, so their clocks tick faster, by about 38 microseconds per day. If we didn't account for this, if we didn't correct for relativistic time dilation, GPS wouldn't work. Your navigation would be off by kilometers. So every time you use GPS, you're relying on my understanding of time, on the fact that time is relative, that it runs at different rates in different gravitational fields. This is not abstract theory. This is reality, proven, verified, used in technology you interact with daily. But let me tell you about an even more extreme example: black holes. Near a black hole, space-time is curved so extremely that time itself nearly stops. If you could hover just outside the event horizon of a black hole, the boundary beyond which nothing can escape, time would pass incredibly slowly for you compared to someone far away. You could experience 1 hour while centuries pass in the outside universe. This is not science fiction. This is what the mathematics predicts. And while we can't test it directly, we can't send someone near a black hole and bring them back, we have indirect evidence. We see the effects of time dilation around massive objects. We observe how light behaves near black holes, and everything confirms the predictions.
Time near a black hole is so distorted that it becomes almost spatial. The closer you get to the event horizon, the more time-like directions become space-like. And once you cross the event horizon, time itself points toward the singularity at the center. You can no more avoid moving toward the singularity than you can avoid moving forward in time right now. That's how warped space-time becomes. Time becomes like space, and escape becomes as impossible as traveling backward in time. This is what I mean when I say time isn't what you think. It's not some fixed, unchanging backdrop against which events unfold. It's dynamic, flexible, warpable. It speeds up and slows down. It mixes with space. It curves and bends. It's part of the structure of reality, not separate from it. And understanding this, really internalizing it, it changes how you see everything. Now let me address something you're probably wondering. If time is relative, if it passes at different rates for different observers, then what is real? Is there any objective reality, or is everything just perspective? This is a deep question, one I struggled with, and here's what I concluded. All reference frames are equally valid. There is no preferred frame, no God's eye view from which time passes at the correct rate. If you're moving relative to me, your time is different from mine. But neither of us is wrong. We're both right. We're both experiencing time correctly for our reference frame. So reality is not a single objective thing that we all perceive differently.
Reality is the totality of all reference frames, all perspectives, all experiences. And the laws of physics, the equations that describe how reality works, they're the same in all reference frames. That's what makes them laws. That's what makes them universal. So there is objectivity, but it's not in any single perspective. It's in the structure that connects all perspectives, in the geometry of space-time, in the laws that govern how different observers relate to each other. Let me give you an analogy. Imagine a cube. Now imagine looking at that cube from different angles. From one angle you see a square. From another angle you see a different square, or maybe a rectangle, or a more complex shape. Each view is different, but they're all views of the same object, the cube. None of the views is more real than the others. They're all equally valid perspectives. And if you know the rules, if you know the geometry, you can translate between perspectives. You can figure out what someone else sees based on what you see and the angle between you. Space-time is like that. Different observers see different slices through space-time, different balances between space and time, but they're all looking at the same underlying structure, the same four-dimensional reality. And the laws of physics are the rules that let you translate between perspectives, that let you understand how what I see relates to what you see. So yes, there is objective reality, but it's not what you think. It's not a single moment, a single now that everyone shares. It's a four-dimensional structure, and we each experience a three-dimensional slice of it, our particular perspective through space-time.
Now let me tell you something that will really bend your mind. The block universe. If time is just another dimension like space, then past, present, and future all exist, equally, simultaneously. The block universe view says that all of space-time is laid out, like a four-dimensional loaf of bread, and what we call now, the present moment, is just one slice through that loaf. Your particular slice, your perspective, but all the other slices exist too, past and future, all equally real. This is difficult to accept. It contradicts our experience. We feel time flowing. We feel the present moment as special, as real in a way the past and future aren't. But that feeling, that subjective experience, it's just that, subjective. The physics tells us something different, and I know this is uncomfortable. It raises questions about free will, about whether the future is already determined, about whether change is real or illusory. These are profound questions, and I don't have all the answers, but I can tell you what the physics says, and the physics says that the distinction between past, present, and future is a stubbornly persistent illusion. Those were my words in a letter to a friend, and I meant them. The universe doesn't have a universal now. It doesn't have a moment that's uniquely present for everyone. It has a structure, a four-dimensional structure, and we experience that structure moment by moment because of how our consciousness works, because of the limitations of our perception. But the structure itself, it's all there, all at once. Or rather, all at once is not even the right phrase, because at once implies time, and we're talking about something outside of time, something that includes all of time. I know this is hard to grasp. It was hard for me too. And I'm not asking you to accept it blindly. I'm just showing you where the logic leads, where the mathematics points, where the evidence guides us. Time is not what your intuition tells you. It's stranger, more beautiful, more profound. Let me ask you something. Now that you've heard this, now that you understand that time is relative, that it's woven with space, that it can slow down and speed up, how does it change how you think about your own life, about your own experience of time? Do you still see time as this enemy, this thing that's slipping away, that you never have enough of? Or do you see it differently,
as something more flexible, more relative, more dependent on your state and perspective. I'm genuinely curious, because for me, understanding the nature of time changed how I lived. It made me less anxious about running out of time, because I realized that time isn't a resource that depletes. It's a dimension that exists, and my life, from birth to death, it's all part of the structure of space-time, all equally real, all existing in a sense. This brought me comfort, especially near the end, but I want to know what you think. Does this view of time make you feel better or worse? More at peace or more unsettled? Leave a comment and let me know, because this isn't just academic. This is about how we experience our lives, how we relate to mortality, how we think about existence itself. And maybe your perspective will help others understand it better, or maybe it will raise new questions. Either way, share your thoughts.
Let me tell you about one final aspect of time, one that brings everything together, the arrow of time. We experience time as having a direction, past to future, not future to past. We remember the past, but not the future. We see eggs breaking, but never unbreaking. We see entropy increasing, disorder growing. This seems fundamental, universal. But here's the strange thing. The laws of physics, at the fundamental level, they don't distinguish between past and future. They're time-symmetric. If you run them backward, they still work. So why do we experience time as having a direction? Why does it flow from past to future? This is one of the deepest mysteries in physics, and I don't have a complete answer. Nobody does. But I have thoughts. The arrow of time, the direction we experience, it's connected to entropy, to the second law of thermodynamics. Systems evolve from ordered states to disordered states, from low entropy to high entropy, and we perceive this direction as time flowing forward. Because our memories, our sense of causation, our experience of change, all of it is built on this increase in entropy. But why was entropy low in the past? Why did the universe start in such an ordered state? That's the real question, and it's connected to cosmology, to the Big Bang, to the initial conditions of the universe. The universe began in an incredibly low entropy state, highly ordered, and it's been evolving toward higher entropy ever since. And that evolution, that arrow, defines the direction of time we experience. But at a fundamental level, the laws themselves don't prefer one direction over another. Time could run backward as far as the equations are concerned. It's just that the universe happens to be evolving in one direction, and we are part of that evolution, so we experience time flowing that way. This suggests something profound, that time's arrow, the feature that seems most obvious and fundamental about time, is actually emergent. It's not fundamental to the laws of physics. It's a consequence of the initial conditions of the universe, of cosmology, of something beyond the local laws we study. And that means our experience of time, the flowing present moment, the distinction between past and future, all of it is in some sense an illusion, or at least not as fundamental as we think. It's a feature of our particular situation in the universe, not a feature of time itself. So what is time really? After everything I've told you, what's the answer? Here's what I believe. Time is a dimension, part of space-time. It's relative, not absolute. It depends on motion and gravity. It can slow down and speed up. It's woven together with space. It curves and bends. And the distinction between past, present, and future, while crucial for our experience, is not fundamental to reality. The universe is a four-dimensional structure, space-time, and we are patterns in that structure, four-dimensional patterns extended from birth to death.
And consciousness, our awareness, it experiences this four-dimensional pattern three-dimensionally, moment by moment, creating the illusion of flow, of time passing. But the pattern itself, it's static, complete, always existing in the structure of space-time. This is the deepest truth I found, and it's both beautiful and unsettling. Beautiful because it reveals a profound unity. Space and time are one. Past, present, and future all exist. The universe is a complete, elegant structure. But unsettling because it challenges everything we feel to be true. It says our experience of time is not the whole truth, that there's a deeper reality underneath, and that reality doesn't flow, doesn't change, just is.
Now, I want to be honest with you. This view of time, this understanding, it doesn't answer every question. It doesn't explain consciousness, doesn't fully explain the arrow of time, doesn't tell us whether free will is real or illusory. These are still open questions, still mysteries, and maybe they always will be. Maybe some questions are beyond physics, beyond what we can measure and calculate. Or maybe we just haven't found the right framework yet, the right way of thinking about these problems. But what I can tell you is this: time is not what you think. It's not a river flowing uniformly for everyone. It's not absolute. It's not separate from space. It's relative, flexible, geometric, part of the fabric of reality itself. And understanding this, really grasping it, it changes everything. It changes how you see the universe, how you think about existence, how you relate to your own life. Because once you know that time is relative, that your now is not everyone's now, that past and future exist just as much as the present, you can't go back to the old way of thinking. You can't unsee what you've seen. And that's what I wanted to give you today. Not just knowledge, but a shift in perspective, a new way of seeing. Because that's what physics does at its best. It doesn't just give us facts, it changes how we understand reality. And time, more than anything else I studied, is where that change is most profound, most personal, most transformative. So the next time you look at a clock, remember, that ticking, it's relative. It depends on how you're moving, on where you are in a gravitational field. It's not the same for everyone. And the moment you're experiencing right now, it's not uniquely real. It's just your slice through space-time, your perspective, your view of the four-dimensional structure that is the universe. Past, present, and future all exist, all equally real. And you're a four-dimensional being, extended through time, not just existing in this moment, but existing as a complete pattern from birth to death. That pattern is you, fully, completely, and it's part of the eternal structure of space-time. That's what time really is. That's what you really are. And once you understand that, everything changes. Hit subscribe to keep exploring the nature of reality with me.